Okay, I think we can start. I see more people dropping in, but I think we have fairly tight agenda, so let's not wait too long. Hello, everyone, and welcome to the Fair Impact workshop on PIDs in complex data citation, semantic artifacts, and related services. It's really nice to see people joining this workshop. Hopefully more will come along. My name is Josephine Nordling from CSC, IT Center for Science in Finland, and I'm the work package lead on PIDs in this project. I think we have a very interesting workshop ahead of us with excellent speakers involved, and this will be also followed by a working session, which I hope will be really useful and interesting for everybody involved with very topical topics being addressed there. So I'm really looking forward to this workshop and all what it has to bring. So let's start. So firstly, before going into my brief introduction to the project itself and the work on PIDs, some necessary housekeeping information is always needed. So please sign yourselves into the collaborative notes document that you can see in the chat as well, and do also write notes and add links there if you like. Also, I wanted to make sure that you're all aware of that the workshop is being recorded, but not the working sessions themselves, so only the presentations and the discussions around those. Please also stay muted unless speaking, and all questions can either be put into the chat or asked vocally by using the raised hand function. I'm sure you're all familiar with these kinds of rules by now, but still good to go through them briefly. We'll also share all presentation slides by close of business tomorrow. So you will get a hold of those as well if you like to go through them. And lastly, we have a quite tight agenda today, so I'm afraid we need to be rather strict with the timekeeping. So that's also good to keep in mind, that try to stay within the time limits, and I will also try and keep track of time myself. This is the agenda. So a short introduction by me and followed by a short interactive session. Then we will hear from the actual experts in this field. So first off, we will hear from Nicola Fiore, and he will present on their use case work done in LifeWatch ERIC. So he's one of 3 use case partners within this subtasks dealing with PIDs in complex data citation. Next, we'll hear from Peter Wittenberg from Fair Digital Object Forum, who will present on citation of digital artifacts. After that, we'll hear from Andreas Rauber and the work on data citation and granularity of the RDA working group data citation. And lastly, we have Deb Agarwal joining us on behalf of the AGU data citation community of practices, and she will be presenting on the topic of complex citation. After this, we will have a short break to get a cup of coffee or stretch our legs, and then we will continue with a working session, which I think will be really interesting for everyone here, hopefully so. And when we reconvene after the breakout session, we'll have a short reporting back, and then we have come to the end of this workshop. Then a few words on the project itself. So Fair Impact is the project name. It's a Horizon Infra EOSC project, which has an ambition to increase the discoverability and interoperability of research objects across disciplines. And you can say that our motto is to expand fair solutions in Europe, and we are trying to work towards those goals. The project started in June last year and runs for 36 months. We have 28 partners and affiliated entities involved in this project, so it's a rather large project. And then over to the fair impact project design, we have 7 work packages altogether, of which 3 are so-called pillar work packages. So we had the one on PIDs, metadata and ontologies, metrics, certifications, and guidelines. And then we have an interoperability and engagement work packages that goes through all or across all pillar VPs. So that's the structure. Here are all the tasks working on PIDs. And we have DataCite leading the task on setting up a coordination mechanism for IOSC PID service providers. Then we have CSD leading the work on integrating PID practices into fair data management. And it's this very task where this workshop comes in. DANCE is leading the PID policy work. And then lastly, we have SURF leading the PID implementation program. This is a piece of work done with 8 different use case partners, where the ambition is to identify and then document best practices when managing workflows, when working with different types of data sets and research objects. And we take the end user perspective in all the things that we do. And the main goal here is to make the content transferable across scientific domains or communities, so that we can reach harmonization in terms of PID minting and using practices. And we are very keen on inviting external actors to collaborate with us as well. And so this workshop is one step, so to say, into that direction. Okay, we have 3 subtasks altogether where the use case partners are working on documenting these best practices. So in addition to complex data citation, we also have use cases working on PIDs in data production workflows and PIDs and sensitive data. And then, as you can see here further down below, we have also some cross-cutting themes, as we call them. For example, research reproducibility, research object type definitions, work around versioning, granularity, etc. So quite a lot, broad spectrum of different topics are being addressed here. Okay, we can skip these. So here you can see all the tools, services, and platforms involved in this piece of work, and the projects and the communities that the use cases can leverage from and exploit synergies with. So quite much involved and quite many connections due to all different directions here. And in addition to the use case presentation on complex data citation, you will hear right after this, presented by Nicola Fiore. We also have 2 other use case partners involved here in this subtask. So these are EMBL EBI and INRAE. And so firstly, EMBL EBI has the ambition to curate and update components of identifiers.org. That's their main task, and the updates will be aligned with community standards and needs in accordance with the FAIR practices. And the goal of INRAE is to work with dynamic dataset management. They will specifically look into what is concretely needed in such a setting. So for example, what set of tools are needed to automatically deliver IDs, and how often these kind of automation should be performed. They are also exploring PIDs for research software, where they use a combination of software heritage IDs and HALID, which is a French open repository allowing citations. So that as an introduction, then I'm keen on asking just a few questions as a warm-up exercise using Mentimeter. You can either scan the QR code with your phone or go to menti.com and enter the code, or you can use the direct link as well. I will stop sharing my screen just for a while, and I can also help out with the direct link for the Mentimeter. Just a few seconds and put it into the chat. there. Now you have the Mentimeter link in the chat. And I will share the results as they start coming in soon enough. So here. Oh, sorry, this was the problem. Bear with me for a second or two. Now I have the correct. Okay, are you ready for the first question? That would be really
Could you give the
interesting to
code in the chat as well, Josephine, please?
Wait, it's difficult to navigate around the code.
Yeah, I've added it. Yeah.
Oh, great. You're quicker than me. That's good. Yeah, so what is your current geographical location? I think it's really interesting to see because I guess it's a bit of a nice spread across not only Europe, but also beyond. Oh yeah, Finland comes across really nicely here, and France as well. Oh, it's good to see Japan as well. So not only European focused, and of course the US. Very interesting. Okay, I think we can move to the next question. So which stakeholder group do you identify best with? And then if you cannot say that any of these, then of course, choose the option other. Quite many researchers, that's good to see. Okay, so researchers mostly, some repository CRIS managers and PID service providers, but also some other categories. So if you would like to share what this other is, please maybe put this into the chat. It would be nice to know as well. I'm going to go to the next and last question. I won't bore you with more of these questions. So this is the last one. Which of the following subject matters is closest to your heart? Okay, so mostly PID enthusiasts, but also a quite even distribution among the other ones. So that's good to see, I think. So this makes me think even more that this will be a really interesting workshop, especially with the working session coming up. So these were all the questions I had in mind. So I won't keep any more of your time. I think rather we should focus on the expert presentations now. So first runner-up is Nicola Fiore from LifeWatch. Please go ahead.
Did you hear me? Okay, I'm sharing also the screen, so I think I can start.
Yes, we can hear you.
Okay, thank you. Good morning to all. I'm Nicola Fiore. I'm the Life for Cherik Service Center ICT coordinator. And today I will introduce our experience with the PIDs. In particular, I will show you how we manage PIDs in the Eco Portal and in our metadata catalogs. Before to start, I would like to just say a few words about Life for Cherik. That is the European infrastructure for high science research in biodiversity and ecosystem. Which is the goal of Life for Cherik, is to federate different distributed research center and legal entities in Europe, but not only Europe, in the world, and create a unique accessible web space where the researcher can find, can discover different kind of digital objects like dataset, services, virtual research environment, in order to be supported to address where the principal, the main key planetary challenges. The first tools that I would like to introduce is the Eco Portal tool, that is our semantic artifact repository. Is the first repository of semantic resources for the ecological domain. Eco Portal has been built using the OntoPortal tool. We are part of the OntoPortal Alliance. This means that we are in contact with a big community of developers on the semantic repository, like AgroPortal, OntoPortal, BioPortal, and so on. We are working together to grow the tools, adding day by day functionalities. Eco Portal could be accessible using ecoportal.life.eu address. Talking about the other tool is the metadata catalog. That is the tool used by LifeWatch to make discoverable the different research objects like virtual research environments, services, workflow, and dataset. Here, so why these main tools? Because in these tools we adopted different PIDs types. For example, for Eco Portal, when we talk about collecting semantic artifact, we talk about collecting ontologies, controlled vocabularies, or named out of list. In this case, we use PIDs for example, the DOI for the semantic artifact. We developed a procedure to obtain DOIs using the DataSite services. We also use PIDs to specify the creators and the points of contact in the that are present in the metadata set. In this case, we push to use the ORCID ID. There are also PIDs for affiliated institutions using the ROR service, which are, I will talk after, but just to introduce, in this case, the main topics open are how to manage the different versions or what we can do for multiples PIDs and also for the provenance. There are also topics in EcoPortal related to the complex and to the dataset evolution. And also topic related to the strategy and the procedure for mining. In the metadata catalog, as I told you before, we use PIDs for the different research objects, so for dataset, for services, for workflow, virtual research environments, and research sites. Also in this case, the DOI is used for the metadata records using the connection with data sites, and but dataset may already have their own PIDs. The open issues in this case are related to the different kind of research objects, because each research object has their own needs, so we need to manage the heterogeneous of the object, talking about services, workflow, virtual research environment, and research sites. Okay, to go deep, I drafted the governance, the actual governance adopted in the different tool. I used for this a notation that is named BPMN, Business Process Model Notation. If you can see in the picture, talking about the EcoPortal, I identify two main stakeholders, the author and the editorial team. The process in this case is a very high level. So an author can propose a semantic artifact. The author should be registered or can directly log in. The first step in the submission process is the metadata description. In this case, in our metadata set, the user should specify the persistent identifier. There are three cases. If the user, if the semantic artifact has a DOI assigned, the resource can be directly submitted and analyzed. In the other case, if there are different kind of persistent identifier that are not DOI, also the process can continue, because for us it's important that a persistent identifier is assigned to the resource. If there are no persistent identifier, the user can do a DOI request. So in this case, there is an editorial team that will evaluate the metadata related to the semantic artifact resource. In case the evaluation is good, we will do a request to the DataSite services and obtain the DOI. So the DOI is released to the author, and the resource submission can continue. So at the end of the process, there will be the notification of the acceptance, and we will publish the resource in the catalog, or if there are some problem in the validation of all the metadata set related to the semantic artifact, also a message to the user for the rejection of the semantic artifact. A similar process is adopted also for the metadata catalog when we talk about data set or single service. Also in this case, we can upset directly if the resource, if the digital object has a DOI or other persistent identifier. In case the proposed has not a persistent identifier, the user can ask to a DOI assignment to our editorial team. The process is similar to the previous.
Excuse me, Nicola, can you
yeah.
maybe wrap things up? We are running a bit late, if that's fine.
Yes, sorry.
No worries.
Okay, in this case, there are the case of a workflow submission. The process in this case is more complex because there are a persistent identifier that should be assigned to the workflow, but we need to assign also DOI or other persistent identifier to the single services that compose the workflow. Based on our experience, we have different PIDs open issues. So when we talk about dataset granularity, for example, because all the semantic artifact, all the digital object, research objects are used in our virtual research environment. So, for example, a user can analyze different subset of data coming from different set of data. So, coming from entire data set with different DOI. In this case, it's important to understand which PID or DOI I should use in the result of in the data set that is the result of the analysis. We can have also a problem because different metadata schema profile could be adopted. There are also open issues related to the workflow granularity, because as I told before, a workflow contains one or more services. Each service is assigned or not a DOI or PID. And so before to assign a DOI to the workflow, all the services that compose it must have an assigned DOI, or it's possible to automatize the DOI assignment process. There are also topics related to the version granularity. What about the version of the entire artifact, version of the entities inside, or linked between deprecated and valid entities? So, we are also issues related to the PID policy definition, because we need to be aligned to the EOSC policy. For the PID challenges, we are working on a prototype that has adopted the blockchain technology. So in this case, we are working to trace all the activities on a particular research object, like that could be a semantic artifact or dataset or services, assign it a transaction hash, so different PIDs managed in an automatic way by the blockchain technology. In this case, we are testing how to manage the provenance and build all the hierarchy of the objects.
Okay,
So
thank you,
for
Nicola,
me,
very much.
That's all.
Thank you very much, Nicola, for this very interesting presentation. I believe if we have any questions, we can maybe take them over the chat, because we are running a bit behind, if that's okay by everybody. And then I would like to welcome the next speaker in the meanwhile. So can you please stop sharing your screen? So next runner-up is Peter Wittenberg from the FDO Forum. So please, Peter, go ahead.
Yep, I hope you can hear me.
Yes, we can.
Okay, thank you for inviting me to this workshop. And thanks for Nicola for the excellent view on what they are doing. So as you can see, I try to talk about citations or referencing digital artifacts. So general objects, digital objects, and try to also to say you something about the FDOs, the fair digital objects in this relation. So before I go to the FDOs, let me briefly go back some years back. So there was a large project where my group was responsible for, as you can see here, it was about endangered languages, collecting all kinds of data amounting to about 25 terabytes of data. And you can see we started in 2000. We'll not talk about all the details. Of course, we made our work. We defined a metadata schema, which all used. We had a decision about the PID use. We used handles at that time, since we had discussion with DOI colleagues, but we couldn't pay the price for all the objects which we are hosting. So we decided to set up our own handle server, which was an easy thing. And that became then later part of the APIC system, which is to create redundancy. So already say two decades ago, so we were on the way to fair data, kind of. We missed a lot of things which are required by FAIR, but as you can see, we started fairly structured. We also created a collection builder tool, which is one of the issues which we are talking about, granularity. And we already had in 2007 our first dissertation, where a lady just put all the things, all the data which she used, all the programs which she used in a big, in a collection, and gave one reference to all this stuff in her dissertation, which was great, right? But we missed something. So it was excellent, of course, that we had a PhD, for example, who did not complain about creating rich metadata, which is still a big problem, as we know. So she did rich metadata, it's all on the web. And she created a PID with help of the tools we provided. So we already were fairly fair compliant in some years ago. And that was good. So we were in a good shape. But at that moment, we missed a couple of things, of course, right? So at that moment, we didn't have any agreements on how to build a collection. So today we have our great RDA recommendations, things which are very good to help creating collection and describe them in a standardized way. And we also did not have any agreements at that time how to define a record, PID record. So we just used some descriptors, some labels which no one else could understand. Let me make one note about granularity, since this is a important issue for this conference, for the discussion, I guess. So, as you can see here, let me share this in. So, so we had lengthy recordings. Also in our institute, we had brain images and other kinds of stuff, which are fairly, how you say, big, large, and there's always the case, you know, what is the digital object? So as you can see, I speak about digital objects, not research objects, but it's the same. It's just a matter of abstraction. So as you can see here, I took the example of a recording. So we had lengthy recordings of events, 2 hours recordings. And of course, in some publications or for some other purposes, people didn't want to refer to the whole 2 hours, right? Of course, the 2-hour recording was in the archive or repository and got a PID, of course. But people had now use now 2 options to refer to a segment or fragment. One is you cut things, you create just a new sequence, which means a new object. If you do this, you have to do, of course, give it a PID and describe it very well, and taking over, of course, harvesting all the other metadata and adding some more metadata about what you did. The other way, which people mostly did, was combine the PID with a fragment identifier. And as you may know, the Handel system allows to do this. So you have the prefix from someone, you create your own suffix, and then you use a Handel mark in this time mark, in this case, in some standardized form from T1 to T2. So that's the way people did it, handled granularity issues. And of course, if you could have a bunch of these segments and you want to combine them again, well, you can create a collection, of course, which is easy. So as you can see, the granularity was mainly driven by pragmatic choices. What would researchers normally do? But you can change these things later, either make segments or bring segments together in collections. So it's really much dependent on the pragmatic view on the use cases which you have in mind. Of course, you need to make statements about the policy you are applying, right? Somewhere, and if you have a repository or if you have a project, you need to make statements what kind of principles you are applying. And of course, when you create, as I already said, when you create a subsegment of something lengthy, then you have to make sure that the context and provenance metadata is provided. Well, as I said, we were close in that project, close to FAIR. And here's a brief look to colleagues, what other colleagues do, which are FAIR compliant, as much as you can see. So it's about the digital specimen, which is used in the DISCO project, which you may have heard about. So it's another S3 project working in biodiversity. And what you see here at the lower left corner is the model of a digital object. So all the information which you can see here, so maps, location on maps, gene sequences, high resolution pictures, what have you, can be many things, classifications. They're all stored and maintained by other institutions, different distributed institutions. What these people my colleagues are now doing is using the FDO, the FAIR digital objects, as a mechanism to structure this huge space, distributed space, and preserve especially the relations. So they're using special DOIs for this, so which have special attributes. I will come to this. And what they, of course, do in this by doing this is creating what you could call a digital twin of the complexity of information, which is out there and existing, digital information existing in very many different institutions. all entities which they create are FDOs. And the FDOs, as I will show in a moment, are self-contained virtual entities. A very important, interesting point is, and that comes close to object-oriented programming, which some of you may know, which was a big change in paradigm in software engineering. You can add to the attributes references to tested operations, which has some very interesting aspects, which I will not explain here. Now, let me briefly mention what are now fair digital objects. It's very simple. It's very simple. Those who are familiar with data side DOIs or with handles, they understand this very easily. You have a PID. The PID points, in fact, to a set of attributes, which then can contain all kinds of different information, like checksum information, type information, or also references to where the data is or metadata is, and so forth. And as I said, it can also include references to operations. If the link to operations is not maintained by the type information. So that's the usual way, which you know from MIME types, that you have somewhere a registry where type is related to operations. So what you can see here is a very simple mechanism. So the FDOs are simple. Important is, of course, that in the FDO forum, we started to make this machinery machine actionable, since you may know that the FAIR principles basically are about machine actionability. And it's a long way to go still, but at least the part of the FDOs is machine actionable as we have specified it now. So all these attributes need to be specified somewhere, right? So when you use something like checksum, it has to be specified, defined and registered in an open registry, so that stupid machines know what they get when they come across checksum. This is not sensational. This is just making things machine actionable. And of course, what we also should have is every repository should that creates or issues PIDs should define the profile, which means the set of attributes which they are using. And of course, they could use different sets of attributes, as we did. And then you should add a profile reference at the beginning, or in the set of attributes. Sorry. So it's all the FDO's stuff is all about machine predictability and machine actionability, and to enable the relation of digital objects to operations. Now, let me just share you, and then I will finish, Josephine, share you one more slide, which is where do FDOs now help? As we all know, if you create your own project, run your own project, and you only share your information with your own people, you don't need any standards, you don't need anything. What we are coming across is, at this moment, that there are a huge number of data spaces evolving, right? So I saw this in Germany, but also at a conference where industry people are around, so the IoT week, many people are creating data spaces. What are data spaces? It's just a choice of technology, as we just heard from Nicola. So a set of technology which has been chosen and a set of regulations. And that then defines a data space. So all is different. So we get a huge fragmentation. If you extend that from Europe or Germany, Europe to the world, you get a huge fragmentation. Everyone uses different choices. And the question is now, how can we integrate these things? And what we believe is that with the FDOs, you have autonomous atomic units which bundle all relevant information, which is relevant for FAIR in this virtual structure, so that you can shift these FAIR objects across all these data spaces, and you still can process them. So I would like to stop here, Josephine, and I hope I was in time.
Yes, thank you very much. I think it was really my fault in the beginning that I went a bit over time, and of course the rest of the presentations will do the same. I think we are even so running a few minutes late. So again, if you have any questions for Peter, please insert your questions into the chat. And I hope we have some time during the breakout session also to discuss more freely. So I'm sorry about this, not being able to vocally ask questions. So next in line, we have Andreas Rauber presenting next. So please go ahead. And as I said in the beginning, Andreas is from the RDA Data Citation Working Group, or having this hat on in this context. So please, Andreas.
Lovely, thank you. So what I'll be doing is I'll be presenting to you the recommendations on how to identify and thus enable citation for basically arbitrary subset of any kind of data at any level of granularity as generic principles. Now we can later on move into discussing how this has been solved and how this has been done by a number of data centers for a range of different types of data. What I'll do is first I'll go into the two challenges that we are addressing here, namely how to deal with dynamic data, because we have left the periods when data was just static and frozen, and the core topic for today, how to deal with the different granularity levels. I'll show you a few of the recommendations and then provide pointers to some of the deployments we have. So the two problems that we have is, if you want to assign a PID to a data set, then usually this data set has to be static. File, a zip file that has the data in it. Because if you just have the same PID, but the data changes underneath, then reproducibility is lost. You might be working on completely different type of data, completely different data than what you thought you were when you got the original pointer, the original reference to it. In reality, we all know that research data is dynamic. So we have new data coming in from sensor data streams or from weekly or monthly updates. We find errors in data that are being corrected. We find data that has to be deleted. And that happens either regularly or at completely irregular intervals. So what people are currently doing is you point either to a data stream and say, okay, we're using that database and that's it, which is obviously not very helpful. Some people add an accessed at date. So I got my data, I used this data source on the 15th of January, which is nice additional information, but really doesn't help me with reproducibility. It doesn't help me getting the same data to compare my method on the same base data and so on. So the only really working approach around that problem is at the moment is kind of an artificial versioning using batch releases of data. So you do whatever a yearly snapshot or a monthly snapshot or a weekly snapshot of the entire database that you dump somewhere, then this one can get a PID and this is a static file that you can cite. Downside of that is obviously that, first of all, you have lots of redundant copies of the part of the data that didn't change. And it takes some time until the next snapshot is being released. So you can't do any studies on live data that are then reproducible or citable because you need to wait for the data to be frozen again as a batch. So what we would like to have is a mechanism that allows us to refer to the data as it existed at any arbitrary specific point in time, not time delayed, not to some whatever batch release cycle. That's the goal number one that we set forth in the working group. The other one is the granularity issue. We have enormous amounts of data, but researchers hardly ever use the entire database. So they use whatever specific rows and columns. We have just seen examples of where you're referring to objects within a object, so certain elements of an object, subsets of a graph, parts of a picture, a bounding box in an X-ray image, a subset of files, any arbitrary subset. How can we precisely identify that subset? So the first most common approach is that you describe it in the method section of the paper, which subset you selected. So saying, okay, I used those 50 sensors and I downloaded data, or I used the data from the 14th of January till the 25th of March. The problem is that these natural language descriptions are usually not precise enough. So the time interval, does it include or exclude the 25th of March? So open or closed intervals. So the natural language description is very ambiguous. And if you have ever tried to reproduce exactly the subset of data following a description in the method section of the paper, you will find out that it is sometimes pretty hard to get exactly to the same number of tuples that were referred to in the original paper. The other common approach is, knowing about this difficulty, is that whenever you extract a subset of data from some data source, that you zip that subset and deposit it somewhere as a dump. That is a meager workaround, but also not very scalable, because here is my half a terabyte of data as a zip file, and here's the 2-page paper that comes with it. And then 6 weeks later, you do an update and you again have to extract the data and store the dump. We have people suggest that you assign identifiers to whatever rows or to predefined subsets of data. These are usually not very flexible, because who says that you always need an entire row when you want to slice by column? Who says that you want to identify all the measurement stations of a specific country? In climate research, you sometimes take measurement stations across a geological region rather than a national boundaries. So whatever we predefine is usually quite limited. So what we would like to have is a mechanism for a machine to precisely identify any arbitrary subset of potentially dynamic data that was used in the process. There was those two goals that we set up for in the data citation working group. We worked on that from 2014 to 2015 for the 1.5 years. Had the recommendations published in 2015, then took another year to run through a few pilot studies, case studies, and early adopters to test whether the recommendations really work. And since then, what we've been doing is helping adopters implement the recommendations for a variety of data sets. Now, how do the recommendations work? I mean, it's basically not rocket science at all. It's basically well-established technology. Let's assume we have any kind of data. I want to say any kind of data. This can be standard relational databases. It can be graph databases. It can be file systems that have hundreds of files stored, image scanned somewhere. It can be multidimensional data cubes, netCDF files in climate research. It can be CSV, comma separated value files. It can be a map. It can be a single image. So any kind of data. And we have some means of accessing that data. That can be a Sparkle relational database SQL query, can be a Sparkle query for a graph database, can be drawing a bounding box on an image. It can be drawing a line selection around whatever lesion in an X-ray image. It can be a list directory command, or it can be an RDF query to a subset of a graph. Any way that we access some part of the data. Let's call that a query in its most general sense. Okay? So we have kind of data, any kind of data, and we have some way of accessing subsets of that data. If we want to assign a persistent identifier to any arbitrary subset of data, we do that by assigning that persistent identifier to the query transparently. The user doesn't need to know about this, but what we do is we store the query and then we assign the persistent identifier to that. How does this work? If we have data that is changing, then we need to make sure, if we want to go back to previous states of the data, that those changes are versioned. So what we do is when new data becomes available, we store the new version, the new data item as it becomes available with the timestamp when it became available. If something has to be deleted, we mark it as deleted with the timestamp that it was deleted. But obviously we do not remove it from the data source because otherwise we can't go back. There is no reproducibility guarantee. If we find an error in the data, so if we need to update a value, we do not override it, but we mark it as deleted with a timestamp and reinsert the corrected value with the same timestamp so that we know which state the data source was in before and after that point in time. That works for pretty much any kind of data. There is more efficient versions, there is less efficient versions, depends on the type of updates you have, but can be done. If a researcher now creates a working set of this entire data source that they want to use, they set whatever face-edited browsing, they define the queries, can be directly via an API, can be by graphical interface where you set your filter parameters. Once you issue the query, we store the query string together with, and I now simplify a little bit, with the execution timestamp of the query against the data source. And that is the thing that gets the persistent identifier. Then there is a little bit of other magic happening that is optional, that helps improve the quality of the data citation. So we recommend storing a hash key of the result set so that we can verify correctness later on. We have recommendations on rewriting the query for normalization so that we have a unique sort, which is important in certain reproducibility settings. But basically the key concept is version and timestamp data source and a query store where we store the query and their execution timestamp. What is also important for us is that for the researcher, nothing, or at least as little as possible, should change with respect to how they interact with their data source. This is all being provided by the data repository. So when a researcher uses a workbench to identify the subset of data, they do it whichever way they're doing it now, via an API, via a graphical interface. They press on, I want my data set, and what they get is the data set and a persistent identifier, whichever persistent identifier you want to use within your community. And this is stored with the database so that you have basically the information on the hash key and a recommended citation text. The persistent identifier resolves to a landing page, and that landing page for the user basically points to the actual subset of data. The fact that this is actually pointing to a query that produces the subset of data is transparent to the user. This is pretty similar to what we find in regular file systems. So whenever you access the file on your laptop or on your server, that file is not a single block on your hard drive. It's distributed across many different segments of your hard drive. When you access the file, you issue a query to your hard drive. The system pulls together the different parts, segments on the hard drive, and puts it into a continuous file that you are then being served when you transfer it elsewhere, you open it in some software. So it's exactly the same mechanism as we know from file system, from RAID systems, and so on. This approach has a number of really nice advantages. First of all, having the query string stored, we have very precise provenance metadata of that specific subset. So no matter what the researcher thinks that they selected, this is the exact query string that precisely describes which subset of data was selected. Having the query allows you to rerun the timestamped query against the timestamped version of the database in order to retrieve the object as it was. But you can also rerun the same query against the current version of the database, thus getting a semantically identical subset of the data, but benefiting from all the additions and corrections that have happened since. And you can obviously also get a diff between the original state of the data source and the current state. So this is also something that is way better than what you get when storing just zip files or dumps of whatever you extracted. And last but not least, for the data center, it's quite nice to understand which parts of the data are being used in which context for which purposes. So that's in a nutshell the recommendations. There is in total 14 recommendations that go into a bit more detail on how to timestamp, how to sort the files, how to ensure that you only assign a new PID to a really new query to a new subset of the database. All of these are summarized on a 2-page flyer. So that's a very compressed version, which is very convenient to get just the first idea of what it is. Then we have a slightly longer paper that describes some of the thinking process behind the recommendations. We have a series of adopters reports and webinars where people show how they implemented the recommendations for a number of different data types. I'll show you a screenshot of some of these in a second. And last but not least, we have a paper recently published in the Harvard Data Science Review that basically brings all of that together. So that's, if you're looking for in-depth insight into this, it brings together the principles that I was just describing to you. It describes the reference implementations that we did initially for relational databases, for graph databases, and so on, for CSV files. And then it reports on a number of case studies where data centers have implemented it in a range of different settings for a range of different data types to be deployed. Here's the 14 recommendations. The first ones are the ones that are really essential: timestamping and versioning and setting up a query store. The recommendations 4 to 10 basically say, okay, how do we ensure query uniqueness? How do we ensure stable sorting, computing hash keys for result set verification? We discuss a bit of what kind of timestamp you should assign and how the granularity works there, up to the way of creating a citation text. Recommendations 11 and 12 deal with what happens if a PID is being called, so that it points to a landing page and that should be machine actionable. No magic there. And recommendation 13 and 14 deal with what happens when the data source changes. So when we move from one data infrastructure to another, when we move from whatever, a file system to a database, or from a database to a column store database. When you really migrate the entire data infrastructure, then you obviously have to migrate the queries and verify the hash keys again so that they compute correctly. So those are the 14 recommendations. Recommendation 14 says, if you do such a major revision of your infrastructure, check that it works out fine. That was mostly to avoid having 13 recommendations, which some people in the group consider to be an unlucky number. So much for data science.
Okay, thank you, Andreas. Do you think you can maybe wrap things up? We are yet again running a bit behind.
Completely. The next slides are not meant to be presented. I just want to include them. They list the number of references and standards that refer to it, and the reference implementations, as well as the adoptions having been deployed. So you can look this up, and the slides will be shared afterwards, so there is no information here. And some FAQs that we provided that answer the most frequent questions, basically, do we need to store every query? Can we delete data? Yes, of course you can delete data, especially if there's legal requirements. Do we need to synchronize timestamps across repositories? No, you don't. There is much simpler solutions for that. So just to show that these things have been tested and verified in a number of settings. The key message basically is we haven't identified a single setting so far where the approach would not have worked. So any kind of data source that we had, any kind of query type that we had in the case studies, we found a solution that made it viable to do it. How complex it is to implement will obviously depend on the setting. But that's basically it. It seems to work for all kinds of data. We can cite everything, even up to the empty set. The one approach that allows you to cite and demonstrate that there was no information available satisfying certain query constraints at a certain point in time, gives you provenance information, gives you metadata to verify authenticity. Turns out to be actually quite useful. And I'm very interested to hear from the group here on settings where they think it might be challenging to implement, or where they see issues with the current proposed approach, and whether we can help in making this come true also for those more challenging settings.
Oh, thank you, Andreas. This was yet another very interesting presentation. And I would again assign people to the chat for any questions to Andreas, or then in the working session also you can join his group if you'd like and discuss more there. So we will be dividing into a number of groups, and we have moderators for each. I will get into that soon. But next in line we have Deb Agarwal from the AGU Data Citation Community of Practices as our last presenter before we have a short break and then the working session. So Deb, are you online? Yes, there you are. Hi, welcome. Thanks for joining at this very inconvenient time for you.
Oh, no problem. But apologies for the lighting because it is the middle of the night for me. So thanks for all the really great presentations before this. Those are all much more mature works than what I'm going to talk about. We're in a much earlier stage of our work, and the effort that we're working on we call complex citations, and I know that's a rather opaque term, so I will explain what we mean by that. But the main point is that, you know, we've just heard about all these different things you could cite, but now when you're actually trying to write that paper and you're trying to cite these things, if you've used a large number of different data sources, and in particular, you know, let's just say more than 50, just to make it large enough that your typical publisher won't actually allow that many references. How do you then cite that data? And so we're looking at how do you build something that allows you to cite all of that data, and including software objects, and in a way that will enable that credit could be assigned after that citation has occurred. So this is, as I said, early work. We've got an RDA working group. I'll give you the pointers to that. But the leaders here are myself, Shelley Stahl, who's here, Martina Stockhouse, Leslie Wyburn, and Christina Brouwenvelder. I'm actually not positive I know how to pronounce her name.
Brouwenvelder.
Thank you. All right. So again, you know, a lot of the challenge is, you know, in a typical paper now, you know, we're bringing data in from many different repositories. I mean, Peter already pointed out that that's something that he's been dealing with as well. And in terms of PIDs, you know, we need the ability for each of those resources to be uniquely identified and include enough information for proper credit. And I want to just start out with a base assumption that many of these resources have requested CC by 4, where the proper acknowledgement that they've requested is citation. Just because it removes the idea of, oh, well, you could just purely group them together and create some other object and that everything will work. Though not necessarily true, but that you still need to figure out how the credit will work. Or at least how the information for the credit will work. And typically today, if you have more than about 20 citations, particularly for data, and even in a data paper, what's happening is that people are being encouraged to put these in supplementary material. And what we're seeing is that then it's not machine readable, which from most of our perspective is the major challenge. But we're also seeing that because then the data wasn't properly cited from their perspective or credited, it's reducing the incentives to share data. And so that's been a real problem. So we've got several use cases. I'm not going to spend a lot of time on them, but I want to point out the types of use cases we have. So the British Oceanographic Data Center, that use case is one where they're taking large data collections from ocean surveys, subsetting them down to create new data products, and then users are subsetting those data products and then using those in a data paper, you know, in a paper. And they want an ability to create something that gives accurate information, similar to what Peter's been doing, to try to enable that in fact the credit can go all the way down to the original contributors in those original surveys. The IPCC example for climate change is really that, you know, this report that they're writing for the UN, they need the ability to have that UN report has the information for each graph and things like that. Exactly, you know, what data was that led to that graph and things like that. And they need that ability to cite that in the report. In the third case, which is one I brought, this is actually a place where it's a small repository, so it doesn't have the resources to do many of these complex mechanisms that we've heard about. But we in that repository, we have over 400 data sets that are typically used in very large combination, and where the original data contributors have requested citation of their individual data set. Okay, so this is just more, this I'm each of these slides just to keep us anywhere near time. We're continuing to get new use cases. I just grabbed one of them. This geochemistry use case gives you another sample of the things that happen. If you're compiling data from literature, you can end up with a very large number of data items that you have to cite in terms of that compilation. And here's just one example of that. We also have some use cases on physical samples and other things that have been coming in. So what we've been doing for lack of a better name, we've been calling this thing a reliquary just to separate it from any of the other items, not because we think it has to be a new mechanism, but because we want a name that identifies the thing we're talking about. So we want to have this reliquary, it needs to be citable in a figure caption. It needs to have the ability to meet all the criteria I talked about, and where, in fact, each of the items in it have a type of PID that is going to uniquely identify it. So something like a DOI, but it can also be PIDs because, as we just heard, there are many reasons why PIDs will be, are also how you might find the exact data component within the data sets that you used. And that this will work across a wide variety of use cases is the idea. And we believe there are going to be many types of implementations of a reliquary, but what we want in the end is these properties that we're aiming for that enable credit, reproducibility, reusability, even more importantly, and where you can build that credit. So what we've put together so far is in the original town halls and working groups that we've had, we've built sort of I call it the cocktail napkin reliquary, where we're just trying to write down what would need to be in this object. What are the types of information that need to be in there? And so we have several of those that have been put together. Here are links to those. And in the end, our goals in this are to really enable that you can cite those specific items in that paper, right? So I not only want this thing that's going to contain all these, but then in fact, in the paper that I'm writing, I could actually indicate which of the items in that reliquary I'm citing at this moment, and have that actually be something that the indexers could gather enough information to be able to then enable that the credit could be traced to that underlying item, and resource, and that those citations, translate into the equivalent of a direct citation. And what I mean by direct is that it's as if the reference was actually put into the paper directly. Again, this is going to support reusability and traceability because we're reaching this point when we put together these large data contributions that are from many sources. When we force that they're put in not with that exact information, we end up with something where you really can't tell which data was used, and all the things that we heard in the prior presentations about how important all of those things are. But another critical element is these have to be easy for anyone to build, right? Anyone writing a paper who has this large number of references is going to have to be able to build these themselves, and across many repositories, and that those could be where there's the information needed to be able to index those and provide the credit as that this was a direct citation. And we'd like to support a wide array of different types of research objects in this. I know these are very lofty goals. I know we won't achieve many of these goals, but that's sort of the early goals that we have. So we've got the working group started. It just started at the last RDA. We're still gathering use cases. So if you think you have a use case that would be a good contribution to help provide information about the broad space, please bring a use case. We'd love to have you join the working group because I think, the critical element to this is finding a way to bring this down to something that can provide, in the end, the indexers aren't going to enable this credit to be traced through large numbers of different types of mechanisms. They're going to want that there's at least one set of rules about how this works so that they can build something that actually could trace that credit. And so getting as broad an agreement about how this might work, and ideally that incorporates all the existing mechanisms as as part of this system, such that we're not inventing a new capability, but in fact integrating together the capabilities we have, such that you can get this additional property on our citation, such that we keep the data contributors incentivized. Because right now, what I'm already seeing with a lot of the use cases I have, that people are, have bought in. They said, yes, I'm going to make my data open. I'm going to let you have this large number of data sets that you serve up together so that the user has an easier time. But then a couple of years after we've done that, they say, well, but I'm never getting any credit. And I'm not getting advanced in my career. I'm not getting the things that I need. And so this has become a critical challenge that we really want to solve. So I'm going to end there. I've got a whole lot more slides that I could present, but I would rather save those for the discussion. So thank you so much.
Thanks very much, Deb. It was really an interesting presentation yet again, and Reliquary, what a genius name and concept. I first heard it at the RDA P20, and yeah, it's really an interesting concept that you have came up with.
And we tried to make it a name that most people would object to,
yeah.
so that we would change it. So it was just a placeholder. I'm a little worried that it's become, people like it so much that now we're going to keep it, but it's not the intent. Okay.
Good to know. Okay, so again, I would refer to the chat for any questions. Sorry for this. We should have a short break now, at least 5-minute break is my suggestion. Sorry for a shorter break. Hopefully you can still grab yourself a cup of coffee or stretch your legs in that short amount of time. And then that would mean that we would reconvene at 24 past the hour. Okay, see you soon in 5 minutes.
Okay.
Okay, are we starting to be back from the very short break? 5 minutes is, yeah, a short break. Goes by really fast. So I think we should maybe move forward. Hopefully most of you, in any case, are back already. So next we will be using this online collaboration tool called Concept Board. So I will take you through how the tool works. It's a really easy to use tool. No need to register in beforehand, so that is a huge plus. I will share my screen just to get you through it. But first of all, I can maybe explain what we are meant to do here. So the idea is that we break out into 5 breakout rooms. You can actually choose yourself which room you want to join, depending on the interest you might have. And you can see in the chat the names and the moderator of each of these 5 groups. So you can choose based on the interest and the knowledge and where you think you can contribute most or have an interest in. So that's how we have assigned this breakout. So I can now show you the tool itself. Here you can see the tool that we'll be using for this session. So you can navigate around the board using this hand symbol. So just drag yourself anywhere you want to go within this board. So you have group 1 up in the left side corner, group 2 is next to it. Then we have group 3 beneath, and group 4 on the right side. And the 5th group is called a hybrid group. So it's kind of statements and questions that would maybe fit as well into the 2 before named groups. So we have 1 moderator for each of the 5 groups that will make sure that the discussion is flowing, and that you, if you have any questions, this person can help you out with that. If you choose this arrow symbol, then that is where you can start actually doing things in this board. And I would, for simplicity reasons, maybe only use the sticky notes. There are some other functions as well, but maybe this is enough to use for this exercise. So here you can choose a sticky note color of your liking. So the color themselves, they do not mean anything. So don't pay attention to that. Just click on the sticky note anywhere you would like to place it. You just click and then it appears there and you can start typing into it. In the lower left hand corner, you can zoom out and zoom in however you like to do it. So this is a short introduction. Sign yourselves in as a guest, accept the terms of use, and then you're free to start using the tool. So I see that many of you are already here. That's great to see. But please do ask if you have any immediate questions. I'm happy to help. Okay. I think I can stop sharing for a while, and then you should be able to choose the breakout room you want to join. Can you find that option? It's down in the right hand corner.
Okay, you all find your breakout rooms. If not, I can assign you also if you can't get in.
Yeah, thank you for me. I'm Paolo Lai. Can
Hi.
you assign me to the group one?
Group 1.
Yes, thank you for your help.
My pleasure. I just assigned you.
Thank you.
Anybody else? Renee, Lorenza, Fulvio. Oh, very nice name.
I think I am adding something to group 2, but I'm not sure that I am
That's okay,
there.
Lorenza. I'll assign you to group
Good.
2.
Thank you.
Hi, Lisa.
Hi.
It seems now I'm not assigned in any group, so
Where would you like to go, Lisa?
probably to group 1.
Group 1. Okay, I'll
Yeah.
assign you. No problem.
Okay.
Can I do this? Where? Why is it not working? Oh, here. Group 1. Yeah,
Okay, thank you.
my pleasure. Paola, Katja, do you need any help? Fotis?
Yes, could you just we are only 2 in the group 1. Do you think it makes sense to?
I think a lot more people have moved now.
Okay, so if you can make me join the group 1, sorry.
Is that
for asking.
Paola?
Yeah, Paolo
again?
Lai.
Yeah,
Lai.
okay.
Sorry.
Let me find you.
Thank you.
Paola, I think you're already assigned to group 1.
Not sure to be in the good room.
You're now in the
Yeah, I
the
was
big
in the
room again. Sorry.
Yes.
Okay, I'll move you to group 2 because you're already in group 1. And then I'll move you to
Okay.
group 1 again. Yeah?
Thank you. Sorry for this.
No problem.
It doesn't work.
Oh my God.
I don't understand why. Is it my fault? Certainly my fault. I'm sorry for this, but
No, that's okay,
I don't know what to
sweetie.
do. Okay.
Well, I'm gonna move you to another group again. And then I'm gonna move you to group 1 again, okay?
Thank you. Thank you. It's
So now you're moving to group 3 and I'll move you to group 1 after you moved.
okay.
Kasaba, you're the only one still in the big room. Would you like to go to a breakout session? Daan,
Ja,
ben jij hier
Yes.
voor de werkpakket 6 meeting?
no, I got an invitation. Nee, ik kreeg een uitnodiging van meneer Turner.
Ja. Maar nu is een workshop voor PID's bezig tot 2 uur.
Ah,
Dus ik weet niet of je in de juiste zit dan.
even kijken. Fair Impact Regular Meeting.
Ja, je mag blijven zitten, daar gaat het niet om. Maar
Nee,
het vervelende is, ze
nee,
hebben geen aparte
bedankt voor de-
meetings gepakt.
Bedankt voor de waarschuwing.
Ja?
Bedankt voor de
Maar om 2 uur begint volgens mij de volgende vergadering. Maar dat is over 13 minuten pas.
Ja, nou deze staat duidelijk op 13. Ah nee, ik vergis mij.
Ja?
Ja, mijn schuld.
Heel goed, geef niet. Doei.
Dag.
We are back in the middle of a sentence.
That's always interesting with these breakouts. You're
Yeah.
just being brought back brutally. Yeah.
I did give notice though.
Yes, you did. You did good.
Sentences are taking longer than a minute, so.
I think we are all back. It was again, yeah, too short of a time to really delve deeper into this. Nice statements and questions. So these are all questions and statements, and that has been sent in to me by all the presenters. So thank them. This was a really, I think, nice way of discussing these very complex matters. But we have a little bit more time before we close the workshop. So I would really like to hear from each and every group, just like in 1 minute or 2. Can you try and summarize what you discussed, maybe? Can we start with group number 1?
Yes. There was a very short discussion because the time was very limited.
Yes.
We discussed about the process, the governance process to assign a DOI, because the question was if could be automated, could be an automatic process, but the answer right now is no, because there are the quality check on the metadata, because we have to assign the DOI that at least for the present could not be automatized yet. We didn't answer to with the stick in the graph, but the other discussion was related to the dataset granularity, because it's important to identify not only the the entire data set, but also all the subsets that could be useful in an analysis or in a virtual research environment. So there was people, Paolo from ANAE, from Rome, that did some suggestion on it. That's all I think.
Okay, thank you. And it would be really, really nice if you could try and type into the sticky notes some of your thoughts that you had. It's understandable that you didn't have the time to do it during, but if you could do it after, that would be really great. Thank you.
Yeah.
And then if we could move forward to Peter's group.
Yeah, also very short time and
Yes.
only few people. So I think we agreed on the fact that there is an endless number of digital object types, right? So, and researchers are created all over the world and create new types again and again and again, sometimes surprising. The question is, we briefly touched, is whether if you have a table, for example, and you have different attributes describing the table columns in measurements or so, whether this is already a new type or not. And obviously, well, we couldn't discuss that, but obviously we are not, I say, convinced that that would be a new type, but that's something one can discuss. So then we had an interesting discussion about instruments, where we had the question how to describe instruments. And of course, software could also be an instrument. And we made a difference between instruments and configurations of instruments. I think that distinction is very important. And there's an RDA group working, and I hope they make it nicely, the definitions. And of course, if you have an instrument, a brain scanner, or what have you, you set some parameters. The instrument remains the same, but so it has a digital object. But the configuration which you're using, where you set filter types and so forth, which you later need this information for calculations, you need to have a configuration, which is also a digital object. And of course, the digital object of the configuration needs to refer to the instrument if you have a separate digital object. And of course, when you do then experiments, you refer from the experiments not to the instrument, but to the configuration. So we discussed that a bit, I think, which is very important. And then we briefly discussed the point which I made here in your in the middle, in the longer diagram, what is common to all digital objects types, and what is different between digital object types. And here we referred also to the FAIR principles and to RDA recommendation. I will not go into detail here, but it would be interesting to get more comments on this. Thanks.
Hey, thank you very much. So over to the next group, and I believe it was Gabi for the next one.
Yes.
Would like to report back.
Hi, everyone. So we were also a small group, and we started discussing around the first question on the citation, and how to make it easier for researchers. And some of the things we discussed were workflow automation and integrating different tools so that it's not burdensome, technically burdensome for researchers to the citations. And yes, then we also discussed that it's easy to cite a data set, but it's more difficult to cite a specific subset of a data set, which is usually what researchers use for the research. And that solution, the solution to that is what we're doing here, discussing and trying to come up with a best practice. We've also referred to Andreas' presentation and the points he made during the presentation. And then we also had a little of a philosophical diversion and talk about abusive power relations, that it's very common in research, that early career researchers do the work, and then someone with a higher position gets the credit of the citation. And now we have the credit taxonomy, where you have to specify which part of the work you did, and that won't prevent power abuse, but at least you have to lie, and it forces someone to lie. And I mean, that's not a good thing, but at least then you have a proof of that, and then that is transparent as well. I think that's mainly what the discussion was about. And then we also separately added post-its on different sections.
Okay, thank you, Gabi. Sounds like you also had a really interesting discussion in your group. Then we have the fourth group with Andreas as moderator.
Mm-hmm. Same very limited time, same very small group, but same interesting discussions. I guess summarizing it, one of the key insights was basically that it is the repository system or the infrastructure basically that can and should take care of addressing most of the questions raised, rather than putting it on the shoulders of the researchers basically. So taking care of the granularity, the system knows which granularity is available, what is the most fine granular solution. It issues the query to the researcher. This is basically transparent. And this applies basically to anything that follows beyond that. So also for the workflow granularity, the researcher identifies a workflow as they are using it at a given point in time. The system knows how this workflow was composed, where the components were pulled from, and basically just refers to the state of the workflow at that given point in time. So it basically turns out that this pushing the resolution to the system would allow maximum flexibility for the researcher without burdening them. And I guess this is one of the key issues that also will lead to finally acceptance by the researchers, because they want to focus predominantly on doing the research rather than doing anything that is, the additional on top work beyond that.
Yes, thank you, Andreas. And over to the last group, which was a hybrid group. There was a lot of discussion around the complexity of the matter itself. So complexity of identifiers of the same objects, that there needs to be links between the objects, that the versioning itself adds another layer of complexity, and also the more granular the citation and identification are in the first place, the more transparent also the citation will be. And here the PIDs come into play. Then we discussed the second point on funder requirements and what they might be interested in which type of information. So here also is really important to be aware that we need to have really realistic goals and really need to think about for what purpose something is being asked. So we need to have the most amount of benefit with the least amount of effort, really, and to prioritize what we really can do. And especially in terms of very small institutions, it's really difficult to add up to all the different requirements. Then we had a short discussion also more into a more complex matter when it comes to the semantics of the identification, and also that there needs to be a consideration of identifiable objects in time and space dimension, and to add an identifier to these whenever these factors change, and etc. So many good discussions, but I think we can wrap things up there. With the interest of time, I think we have already used our time well enough. So I would like to end the workshop here. Thank you to all the presenters, all the participants, and all your active engagement. It was really a nice and interesting workshop, and stay tuned for more work being done, and also our deliverables once they come out. And all presentations will be sent to you by end of tomorrow. So stay tuned for those. Okay, thank you, everybody.
Thank you. Thank you for
Thank you.
the
Bye-bye.
opportunity. Goodbye. Bye.